Okay, so if we take a look at our notes for today, what we're starting with is simplifying rational expressions. So what you have to keep in mind whenever you hear that term rational expressions, that is our fancy talk for fractions. So what we are dealing with are fractions. So what we're going to be going through is when is a fraction undefined, how to simplify fractions, and then we're going to do a little multiplication and division with fractions. See? Fractions. Do you not know how to spell fractions? No. So undefined fractions means that your denominator is a 0. We can never have our fraction denominator be a 0 because ultimately what that's saying is that you're trying to divide by 0. If I have 4 cookies that I'm trying to break into 0 groups, can I actually do that? No, you can't do that. If you ever get a little bored, you can ask Siri on your phone what happens when you divide by 0. She's a little mean, I'm going to warn you, but she'll tell you what happens. You cannot divide by 0. Okay, so when we are trying to find what makes the fraction undefined, because we're going to have to do that a lot, all you have to do is take your denominator, so in this case a, and you set it equal to 0. So that one's pretty easy. If a equals a 0, your fraction is undefined, is what that's saying there. So let's try the next one. So again, take our denominator, set it equal to 0, so x plus 6 equals 0. So now all we have to do is solve for x by subtracting our 6. So when x is a negative 6, your fraction is undefined. So for this last one, x squared minus 9, again, take your denominator, set it equal to 0. This is what we spent all last class doing, x squared minus 9. What do we do to solve it? Dots. Good, Cyrus. What does this come into? X minus 3, and then x plus 3. So I'm thinking back to a couple years ago, and even last year, we set both sides equal to 0. So we get a positive 3 and a negative 3. So that one has 2 answers. If x is either 3 or negative 3, your fraction is going to be undefined for that. Okay, next one, simplifying with exponents. And the other thing you have to remember, they're not always going to tell you, but you have to have positive exponents only. So if you've got a negative exponent in there, you need to fix it and make it a positive exponent. So this is very similar to what we were doing. So over here looking at number 1, we've got to find what is the largest number that's going to go into 44 and 12. 4. So we're going to divide them both by 4. Divide by 4. That's going to give me 11 over 3. And then we'll subtract our exponents. So 3 minus 2 gives us x to the first. 6 minus 11 gives me y to the negative 5. But can I leave it that way? No. What's going to move? The y. The y has to move down here. So we get 11x over 3y to the 5th. Second one, largest number that goes into negative 12 and 36. 12. So I'm going to divide them both by 12. So I get negative 1 over 3. So then our x's, what happens to them? Cancel, because it's the same exponent. 8 minus 10 gives us y to the negative 2. Now, is there a z in our numerator there? No, so we can't do anything with a z. We're just going to leave it down here with the 3 because there was no other z to, combine it with. So now what do we have to move? The y has to come down, so we get negative 1 over 3 y squared z. You do not have to put the y first. I was just always had it ingrained in my brain from my teacher's alphabetical order, so y would go before z. But it really doesn't matter. So now these simplifies are a little bit more difficult because we don't have just monomials this time. Up here we had one term over one term and then one term over one term. Here we've got binomials, we got some trinomials in there. So when you're trying to simplify those ones, what you want to do first is you want to factor if you can. And then you cancel stuff out. So you want to try to factor first and then cancel stuff out. So when you're canceling, they have to be something that's identical to each other. So let's see here. Nope, that one doesn't even work out the way I want. So let's take a look at the first one. Are these exactly the same? X minus y, y minus x, not exactly the same. I could rewrite this up here like this with a -1 out in front, and then I would change the signs. And then it's exactly the same now. I now have y minus x over y minus x. So these would cancel each other out. What would I be left with? The -1. So our answer for that would be -1. The rule that lets me do this is if I rewrite this as it is, it would be -y plus x. Aren't my signs just the opposite as my denominator there? So all I did was factor out a -1 to make them exactly the same so I could cancel. This is what we call our -1 rule. If it's subtraction and it's the same letters, just reverse order, they cancel out to give you a -1. All right, let's try our second one there. We have 3b minus 3a over a minus b squared. Can we factor anything out of the top? Yes. The 3. GCF factor of 3. And then in the bottom, I'm just going to write my a minus b twice. Since it's a minus b squared, I'm just going to write it out twice. So now, are those exactly the same? Do we have anything in the top exactly the same as anything in the bottom? No. But they're close. The order is reversed. It's subtraction and the order is reversed. So I can cancel this with that and make it a -1. Again, that's our -1 rule. In that situation, yes. Generally, yeah, it's easier if you keep it up in the numerator. Doesn't matter where it goes, that just makes it easier. So this is 3 times -1 over a minus b. So that would be our final answer. When you reduce that stuff, it's always going to be times by what's ever left. So taking a look at our third one, let's start our factoring. What kind of factoring do we have in the numerator? Dots. So we got x minus 5 times x plus 5. Denominator is a trinomial, but they're trying to trick you because they put the numbers first. So you just have to remember to put your numbers first when you factor. So my 5 and my 1 go first in the parentheses. My x's go second. We just have to figure out where the signs are going to go. So kind of in your head, you should be trying to do your little smile and your big smile. If I make this one positive and that one negative, my little smile would be a 1x. My big smile would be a -5x. So those would end up canceling each other out. Or, I'm sorry, that would end up giving you your -4 in the middle. So now, x plus 5 and 5 plus x, those will cancel each other out because, remember, addition is commutative. It doesn't matter what order I add the two things in. It's exactly the same. So these can just cancel each other out and I don't have to put the -1. Again, because it's addition. So then we're left with x minus 5 over 1 minus x. And no, you cannot cancel out those x's. I get asked that question a lot. Those are all attached. So either it's the whole x minus 5 or it's nothing. And then the denominator, it's either the whole 1 minus x or it's nothing. Okay, questions so far? All right. Let's go to our multiplication and division. So if you have ones like this first one where, again, you have monomials, you got one term over one term equals one term over one term, For these ones, it's easier to multiply first. And then you want to reduce like we were doing out in the front page. And again, that's just for the ones where you got one term over one term equals one term over one term. So when we multiply our top, 6 times 10 gives us a 60. Add your exponents on your x's. We get x to the third and y to the fifth. Then multiply the bottom, 4 times 9, 36. We get x to the 10th and y to the 9th. So now we'll reduce. What's the largest number that goes into both 60 and 36? Larger number than 6? 12. So 60 divided by 12 is 5. 36 divided by 12 is 3. So now we subtract our exponents, so we get x to the negative 7th and y to the negative 4th. So now we just have to move those two things. They both go down. So we get 5 over 3x to the 7th, y to the 4th. That would be our final answer for that one. So for these other ones, what you want to do is you want to factor first when you have a binomial or trinomial. So our first step is going to be we're going to factor. Second step, you want to then cancel 1 from the top with 1 from the bottom. And it doesn't matter which fraction they're in. It's just 1 from the top, 1 from the bottom. That is the ruling for it. And then you just multiply what's left. So let's take a look at this one that's labeled number 2. So we're going to start factoring first. We've got a trinomial in the top of that first fraction. So I'm going to set up my 2 sets of parentheses. Y squared minus 2y minus 3. Who thinks they know how that factors? Nobody? What multiplies to give us 3? 3 and 1. The 3's got to be your negative to give you your negative 2 in the middle. How about 2c squared? I was trying to trick you. That one doesn't factor. Same thing with 4c squared. That one doesn't factor either. So then we got a GCF factor in that last one. What's our largest number and letter combination? 4y squared. So that gives us y minus 3. Alright, so now we can start canceling. Y minus 3 is going to cancel with y minus 3. 1 from the top, 1 from the bottom. The c squared will cancel with the c squared. Because again, 1 from the top, 1 from the bottom. What do you think will happen with our 4's? Cancel 1 from the top, 1 from the bottom. 4's are gone. So then what we have to do is we have to find what's left. What's left in our numerator? What did we not cancel? The y plus 1. In the denominator, we didn't cancel the 2 or the y squared. So we're going to multiply those two together and get 2y squared. And that's our final answer. Okay, let's try number 3. I'm going to set it up to start my factoring. What's our GCF in the numerator of the first one? 4. And then we've got x minus 2. We've got a trinomial underneath that. So 2 sets of parentheses. We're looking for things that multiply to give us 18. 6 and 3. Which one's my positive? 6. So x plus 6, x minus 3. 3 minus x. Nothing to factor there. There's no GCF, nothing like that. And then x squared minus 4. How does that one factor? Ooh, close. X plus 2, x minus 2. Okay, so let's start our canceling. What can we cancel? Yep. X minus 2, x minus 2. This is the one where we can cancel this, but it becomes a negative 1. It happens if it's subtraction and the order's flipped. Yep. Well, no, because addition's commutative. Doesn't matter which order they wrote that one in. It'll cancel each other. Alright, so we're left in the top with 4 times negative 1. So that gives me a negative 4. Over x plus 6 times x plus 2. Now you could go through and multiply those two out and get another trinomial, but you don't have to. And I don't recommend it because if you accidentally make a mistake, then you're going to lose points for that. So just leave it as the factored form, as we call it, which is what this is, and you'll be fine. Alright, let's take a look at the fourth one. 6x squared plus 60x plus 144. Just looking at those big numbers, first thing that comes to my head is I think there's going to be a GCF there. 6. So we got to pull out our GCF of 6 first. So that gives me x squared plus 10x plus 24. But is that factorable again? Yeah, that's why I didn't put my fractions lines yet. That one is factorable again. How are we going to factor x squared plus 10x plus 24? Well, multiplies to give us 24, adds to 10. 6 and 4. So plus 6 plus 4. And then I cross that one out so I don't get myself confused thinking that I need to use that one. How about the denominator there? How's that one going to factor? It does. It does. No. GCF of x. So it's x times x minus 7. Alright, how about the top of the next fraction? GCF again. And then x plus 6, can't really do anything with. So that stays as x plus 6. Alright, what can we cancel? X plus 6 with x plus 6. No, because remember, it's got to be one from the top, one from the bottom. Those are both up top. There's one other thing we can cancel. The x's, yes. And then there's nothing else we can cancel. So in the numerator, we would have x times x plus 4 times x plus 4, because we've got 2 of them up there. And then it's over x minus 7. So again, remember, since there's 2 x plus 4s up there, the other way that they could write this would be 6 times x plus 4 squared over x minus 7. And if this were a multiple choice question on the Regents, that's the way you would see it. So you got to remember, if you got 2 of them there, they're going to write it as a squared. If you... Yes, the one that's more simplified, which would be the x plus 4 squared. Alright, so our last one on this page. What is different about this one? This is division. You guys remember what we do with division of two fractions? Keep, change, flip. Always makes me think of KFC. Keep, change, flip. So I'm going to try to do a couple things at once. I'm going to factor and do my keep, change, flip in one step to save us a little bit of time. So first fraction, we're keeping it the way it is. So my numerator, when I factor it, is going to go right in the numerator spot here. So 2x squared minus 1x minus 1. So remember, for our first term, we would have 2x and x. There's only one way to multiply to give you 1, and that's 1 times 1. We just have to figure out where our signs are going to go. Which one do you think should be our positive? The one with the 2x or the one without the 2x? With the 2x would be our positive. That one's going to be our negative. Remember, you should be doing that little smile, big smile check in your head. Little smile would be a positive 1x. Big smile would be a negative 2x. When you combine those, there's your negative 1. So our denominator here, we got to do more factoring. That one's a little bit easier. Perfect. X minus 4. X plus 2. So then as you can see, I already set it up. I already changed my division to a multiplication sign. So now I got to flip the second fraction. So when I factor my numerator, I'm actually going to write it down here. So what's my GCF in my numerator there? 4. And then I get a 2x plus 1 when I pull out my 4. So then my trinomial gets factored up in the numerator spot. Which, how does that factor? 2 and 4 again. X plus 2. X plus 4. Alright, so let's start canceling. 2x plus 1. 2x plus 1. X plus 2. X plus 2. Nope. Nope, can't do that. So we're left with x minus 1 times x plus 4 over 4 times x minus 4. And we got 1 left for our notes. That's a little bit of a doozy. Okay, so let's take a look at this one. We got 3 fractions this time. We got the first one times the second one divided by the third one. So, these ones are still going to follow your keep, change, flip rules. Whichever 2 fractions are around your division sign are going to follow the keep, change, flip rules. We don't have to change anything when it's multiplication. So that means this first fraction, you're not going to flip that at all. So the only one that gets flipped is that last one right there, because it's after the division sign. And that's the way it always works. Whichever one is after your division sign, that is the only one that gets flipped. So let's start factoring. For the first fraction, we got 2 trinomials, one in the top, one in the bottom. So how does that top one factor? Multiplies to give us 6, but are one number apart. Oh, come on, what multiplies to give us 6? 3 and 2. So x minus 3, x plus 2. Alright, the one underneath it, what multiplies to give us 15? 5 and 3. Which one's my positive? No, 5. I want a positive 2 in the middle, so my 5 has to be the positive. Alright, the second fraction is also not going to flip. We got a GCF first. What's my GCF there? 2. I write it up above because after I take out my 2, what do we have? x squared minus 25, which is dots. We factor again. So that would be 2 times x minus 5 and x plus 5. I could see that was coming because I had that x squared in there and my GCF didn't have any x's in it, so it was kind of my hint. I was probably going to be factoring again. How does our trinomial below that one factor? Well, multiplies to give us 5. Negative 5. Positive 1 would give us our negative 4 in the middle. So now we change the division sign to multiplication. And we are going to flip that fraction. So x squared plus 5x plus 6. How would that factor? Yep. And that goes in the denominator. We got to flip it. So it's x plus 3x plus 2 in the denominator of that last fraction. So then 1 minus x squared, that is a dots factor. So that would be 1 minus x and 1 plus x. Alright, so now we got everything factored out. Now we get to cancel. There's lots of canceling in this one. X plus 2, I heard, with x plus 2. X plus 5 with x plus 5. X minus 3. And x plus 1 with x plus 1. And x minus 5 with x minus 5. So let's see here. We're left with a 2 and a 1 minus x in my numerator. What's left in the denominator? X plus 3. That's your answer. So from all of that down to just that little one. It's crazy.